Have you ever looked up at the night sky and felt a sense of wonder? I know I have. We see stars, planets, and vast dark emptiness. It all feels so real, so solid, so three-dimensional. But what if I told you everything you see, everything you are, might be an illusion? Not a dream exactly, but something like a projection, a very, very convincing hologram. This sounds like sci-fi, right? But top physicists are seriously considering it. They explore the idea that our 3D universe is a projection of information stored on a distant, two-dimensional surface. This isn't just a wild guess. It may solve one of science's biggest mysteries, a puzzle baffling physicists for nearly a century. Two amazing theories describe our universe. Relativity rules the very big, galaxies, gravity. Quantum mechanics rules the very small, the weird world of particles. But they don't play nicely together. They contradict. Two instruction manuals, different languages, conflicting directions. It's called quantum gravity, the two pillars of modern physics. Einstein's general relativity says gravity is curvature of spacetime. Mass bends spacetime, and spacetime tells matter how to move. It explains falling apples and Mercury's orbit. Quantum mechanics rules atoms, electrons, photons, the bizarre and probabilistic. Particles can be in many places at once, popping into existence. But what about something both tiny and massive, like a black hole's core, or the early universe? Combine the equations and the math spits out nonsense. They mix like oil and water. A unified quantum gravity could unlock where we came from and what's inside black holes. Enter the holographic principle. A hologram looks 3D, but its info lives on a flat film. Light reconstructs the 3D image from a 2D surface. Likewise, our 3D space and time may emerge as a projection from a lower dimensional reality. All information could be stored on a two-dimensional boundary of the universe. Reality as a 3D movie, playing from a 2D disc, the cosmic boundary. Gerard 't Hooft and Leonard Susskind pursued a crucial clue. Maximum information in a region scales with boundary area, not volume. If surface area sets the info limit, maybe the interior is a projection. Perhaps the 3D world isn't fundamental. Maybe true reality is the 2D surface, and we are the hologram. Black holes are our extreme laboratories, where relativity and quantum mechanics must both apply. A massive star collapses, making a region nothing can escape. The point of no return, the event horizon. Relativity says only mass, spin, and charge remain. Information seems lost. Bekenstein and Hawking found black holes have entropy, information content. Crucially, it scales with horizon area, not volume, a holographic hint. It's as if the horizon records everything crossing it. Hawking showed black holes radiate and eventually evaporate. So where does the stored information go? Maybe Hawking radiation isn't random. It's subtly encoded with the information. If so, quantum mechanics survives. The challenge is to show the precise mechanism. In 1997, Juan Maldacena made a breakthrough. A concrete example of holography in action. A Rosetta Stone for two physical languages. Inside, a gravity theory in anti-de Sitter space. On the boundary, a quantum theory without gravity. He found their mathematically equivalent, dual descriptions. Black hole questions in the interior become tractable particle problems on the surface, a powerful tool to translate hard problems into easier ones. This bridge is strong evidence holography captures something real about quantum gravity. ADS isn't our cosmos, but it's a vital working model. If the universe is a hologram, does reality have a resolution? Is spacetime made of fundamental pixels? Zoom in to the Planck length, far smaller than an atom. Holography hints the pixels might be Planck-sized. Detecting them is like spotting an atom on Pluto with binoculars. The holometer searched for correlated holographic noise, spacetime jitter. It ruled out some simple models but didn't kill the idea. New experiments and data analyses are underway. Even the Big Bang's afterglow is being checked for holographic fingerprints. Finding spacetime's pixels would be a discovery for the ages. We've journeyed from galaxies to quantum realms and black holes. Holography offers a strange yet elegant path toward quantum gravity. Our 3D world could be a projection from a distant 2D surface. ADS CFT gives it mathematical footing. The information paradox makes it compelling. But it raises profound questions. Where is the boundary? At a cosmic horizon? Or something else entirely? What information is written there? Code like bits? The laws and the state of everything? If reality is generated from code, does that imply a coder? Science can ask, but may not answer. ADS CFT fits a special spacetime. Extending holography to our accelerating universe is an open challenge. Is holography universal, or just for certain theories? We don't yet know. What about consciousness and free will? Are our choices predetermined by boundary data, or emergent within the hologram? Holography challenges our basic assumptions about reality and our place in the cosmos. One thing is certain, the quest to understand it is just beginning.